Sometimes we travel so much, we're racing so much, a lot of times we don't get the opportunity to visit the places that work with us. And Brian at LME has been awesome. I recommend anybody with any LS, LT stuff come here. But not only because he's a hell of a dude, but man, the places, you can eat off the floor.
I've been to a bunch of engine places, and I've never ever seen one of those.
Yeah. So we're going to show you guys around a little bit. I'm going to introduce you all to Brian, stuff like that. But this place is unreal. I mean, like, legitimately, I'm kind of at a loss for words. I've been in, how many engine shops have you been in your life?
A lot.
And I've been in a ton, and this is
amazing.
Top couple for sure.
They're at the top of their game. Right?
Yeah, and we got a motor that doesn't have the blower on it yet, that made 680 horsepower, naturally aspirated, and it's built and set up for a supercharger. Yeah, I feel like you had inside info. You're not supposed to say that. You're gonna have to edit that, obviously. No. So anyway, we're excited. We're gonna show you guys around if Brian's cool with it, and just look at this place. It's just badass. So.
Yeah, when we moved into this place, it was just an open shell. It was like a warehouse building.
Yeah.
So we put in the ACs.
So why?
In our original
in
our original spot, 2,500 square foot shop.
Yeah.
We didn't have any money.
Yeah.
But we spent our first money on AC.
That's cool. Was that for the employees?
Yeah. Well, we were the only employees, so it was for us, right?
Okay.
But in Houston, and I've worked in shops where there's no AC, and you're in Houston, and you're just drenched with sweat. Ultimately, the productivity goes up. I mean, and it's just a nice place, So today's a beautiful day. We got the doors open.
Yeah.
But when it's 100 degrees out, and it's
in the Houston
70
heat.
in here with no humidity, you're loving it. So.
Yeah. So today we're at LME in Houston. I'm picking up a motor that I had Brian do for me, and I just thought it would be cool to let you guys just check this whole facility. It's one of the nicest places I've ever been to when it comes to an engine facility. And I'm excited to just learn things. And he was kind of explaining the air conditioning, and it makes sense. In Houston, it's hot. You want your guys to work, and you want them to be comfortable. Put them in air conditioning. It ends up being something you spend money on that some people go, man, that's a waste. But if your productivity goes up, it makes money.
And even the product, right? So I mean, the machinery, measuring stuff. When you're measuring aluminum, we should keep a constant, temperature, just
because everybody knows heat and cooling, contraction, expansion, all that type of stuff is factored in.
Just gives us a nice even feel.
True.
So
where are you going to start?
I'll tell you a little bit about our process, and that's really what I feel sets us apart from everybody else, is that we've honed in and developed our process over the last 20 years to really fine tune and get to a point where we've broken everything. We've seen not every, but we've seen a lot of failures. We've seen a lot of all the things that go on with an LS, LT engine or any engine. Yeah. And just incorporating all of those into every engine build. And that's kind of this, I'll kind of show you what we've got, but the progression of that learning is now, we're 20 years in, so we feel like we're building the best engine that we've ever built, right?
Yeah, right. So this is where everything comes.
Well, this is where we'll tear down an engine.
So this is all customer stuff coming in?
Yeah, this is all engines coming in. So we'll take apart an engine in this location here, usually on that cart there.
Yep.
Take it apart, do our diagnosis of what might have went wrong, if there even is a failure. A lot of stuff that we're doing, like new Corvette engine, they're just pulling it out, sending it to us. So not anything necessarily wrong, but we'll clean and inspect the engine back here. So we've got a couple ultrasonic and jet wash here that we can start cleaning the parts. We'll bring in new engine blocks as well. They'll get deburred in a different location, and then everything starts with the machining process back here. So the first step, once we've deemed the block as a usable core, let's say, or if it's just a brand new block, all of these here are new engine blocks. Okay. So we got your Hemi there, but new LSX block. These are LTs. Got a new Dart right there. More LSX blocks. And then this is a new L8T like you got. Yeah. And these are LT blocks, LS3. So these are new engine blocks that are ready to be line home for the very first step of the project.
Now, these are all new, only new, not like pull-outs or anything like that? Some of them could be.
This one here is a used block, but all the rest of these just happen to be new.
Yeah, this is from my buddy Ron and
there you go.
There you go. That's cool. So, and you guys are getting into the Hemis now.
Yeah, we're doing a lot of Hemis. I mean, they're just so popular. The cars are affordable. You know, there's a lot of options and now with the new track box stuff and just everybody, the TRX, everybody's going crazy. So we're building engines for TRXs like every day.
Man, that's awesome. So expanded what you guys doing, going from LS to LTs. Now you're doing some of the Dodge stuff.
It just makes sense. I mean, the Hemi is a great platform. There's a lot of similarities dimensionally
for sure
to a LS, to a Hemi. We've got some really nice CNC programs that we've been working on for the cylinder heads. And, it just makes sense. It's a really great platform. So this is the first step of the whole process. So we'll take a block, we'll throw it up. Here it'll be upside down to where the mains of the block. The mains are here in line. What we'll do is we'll cut the caps so it actually makes the main housing bore diameter smaller when you cut the cap.
Okay.
Cut them all, and then we can hone all 5 main bearings, main housing bores out at the same time. So they're not only dimensionally where we want it, but they're also in line with each other. That's this is the foundation of the entire build right here. So that's why we do this process first.
So is a factory block, whether it be an LSX or a factory already run block, is the line bore out in some cases? You guys straighten them up?
So they're not on the size that we want. So maximizing or optimizing bearing crush is where it's at for the foundation of any race engine.
Okay.
So the bearing crush is the only thing that keeps your bearings from spinning. So we have a specific main housing diameter that we use that is actually a little bit different than what's even in the bearing book.
Okay.
So by optimizing that, we feel like
you control the bearing crush by starting out with the size that you want it to be.
Some machinists actually attempt to adjust bearing clearances by adjusting the journal diameter, which is never the right way to do it because you don't want to ever sacrifice the bearing crush. All right. So we optimize that, and that establishes the center line of the mains. From there, we can go over to the CNC, and everything else is machined off of that. So if you've heard the term a blueprinted block, right? So the blueprinting is just as you look at a house blueprint, it's dimensions from different points to their cells. So everything is referenced off of the main housing bore center line. All right. So once we establish that, we know we're good. We can go over to the CNC.
Okay. So the block goes from here over to the CNC machine. Okay.
So we just got done pulling one out of here. You can still grip it with tool in here. So all engine blocks will come in and be put into this 4-axis CNC machine. So we have lugs that register off of the center line of the mains and the center line of the cam.
Okay.
Once those lugs register into this fixture here, the center of rotation, we can rotate the block 360 degrees. The center of rotation is the center of the mains. So we can then probe, and our programs are all set up off that center line. We can cut, like on an LS, we'll cut the block to, say, a 9230 or 9240 deck. Perpendicular to the mains now, again, blueprinting. So you've heard 90-degree V8. We cut the deck surfaces truly perpendicular to the mains. So that's something that is off typically from a production piece. You're correcting, like you put an aftermarket block in there. They're kind of more mass produced, right? So they're just banging out the deck surface, where we're kind of we are correcting it to a true,
making the deck surface perfect.
Not only in the surface finish, but also its height and its angularity to the other deck.
Okay.
So we can cut that. So we have a bunch of different programs that we've spent the time to pre-program. So if we're on an LSX block, let's say we want a 9240 deck, 4125 bore, half-inch studs, and receiver grooves because we're using the hoops. Right. We can call up that program and just run it. We have all of our tooling preset, and it does it. And it goes to town.
So you load the block in. This machine fixes the deck surface. This does a few things.
So it bores it, decks it.
It does that. All machining, basically.
All the machining except for the hone. It'll clearance for stroke. You know, if we're running, say, like a 4125 stroke, or
it'll cut the bottom of the cylinders.
Cut the bottom of the cylinders. There's really not much other specialty machine work, and we can flip it up if we run like a Jessel belt drive. We flip it up on the end, and we'll run a indicated in. We'll run a program for the Jessel belt. We do the lifter bushing. So if we're running 937 lifter or 904 lifter bushing, we can go in and typically a lot of shops will do it in a Bridgeport, like a regular mill.
Yes.
We can just go in and precision punch those holes in relation to where we go off is the thrust surface and the dowel pin. That's where all of your data points are related to, your X and Y axis on the block.
Wow.
So once that's done, we kind of have a rough machine block or a finished machine block that's ready to go to the cylinder hone.
Okay.
All right.
So cylinder hone, a guy that's honing the cylinder?
Yep. So
or
we have basically a CNC cylinder hone.
Okay, a CNC cylinder hone.
So what we're doing here is right here is roughing out the block. Okay. If you look in here.
Good looking here.
So this is a billet block.
Yeah.
It runs no water. And what we're doing is we have a torque plate on the other side. But no torque plate on this side. So we're just roughing it out, getting it close to the finished size. Okay. Then we're going to come back and finish the other side that has the torque plate on it.
Essentially, you'll rotate it over, put the torque plate on this side, and finish hone the other side of the block.
Exactly. So it's kind of like not putting too much heat into the block, so we can get it close with that, then switch over to the torque plate side, finish it out, and then go back. So this is a very critical step, of course. Not only do we want the cylinders perfectly round and straight the whole length of the cylinder, but we also want them at the correct surface finish. For sure. So we have a recipe for each different block to achieve the surface finishes that we're trying to achieve. So we have these diamond hones here. We'll really make a couple of different honing surface finishes for, like, let's say if we're running M1 compared to gasoline, something like that.
Is it gonna have heat in it? Is it going to have water in it? Is it going to have alcohol? Is it going to have, I see what you're saying.
Right, so really what it comes down to for surface finish is that on many of the applications we're trying to achieve the same surface finish for different blocks, but it takes a different recipe to get there for that engine block. So an LSX block will hone differently than a dark billet block, or the liners are different, different hardnesses and such. So we've done all of our work on that, and we have a specific way we achieve the surface finish. So we can check that surface finish with a profilometer, and what that is just a measuring device that can measure in micro inches the surface finish. So our crosshatch, basically looking at it under a microscope, we know the peaks, valleys, how deep those are, and to get us the correct oil retention. That's really the most important thing, which has a direct result on the longevity of the engine, but also the ring seal, and how efficient that ring seal will be.
Probably even affects detonation and a couple other things.
Yeah, exactly.
Too much oil in the cylinder.
Exactly. Yeah. So we want good oil retention, but with good ring seal.
Yeah, for sure. Yeah, that's crazy.
Yep. So once that's done, so let's say we've if it's not going to need any other special machining. The block will now be ready for final deburring, inspection. That's all done down here. We'll deburr it and get it ready for the cleaning.
Awesome.
So pretty straightforward. I could actually show you real quick.
Try and hold you. Thank you.
The crankshaft balancer. We'll set up crankshaft in here. We'll measure the rotating and reciprocating masses of the rotating assembly. And create these bob weights. So these bob weights are a representation of the big end, the small end, rotating and reciprocating, the piston, the pin, the rings, the bearings, and then we add in 5 grams for oil. So parasitic oil is going to be on the crank. Once we spin it up, the out of balance will be transferred to these stanchions. It'll tell us where to add or remove material in relation to the drill here. And this is connected to the snout of the crank. Pretty straightforward. We either add or remove based on what it needs. We get it to a 1/4 ounce inch tolerance. That's good for 10,000 RPM. So
you guys use, and just for guys that don't know, you guys use Mallory if it needs weight.
Exactly.
So you'll drill a spot if it needs some taken out. Make a lightning hole, if you will. And you'll add Mallory in a certain point in a certain spot if you need to.
Exactly. So if you look at one of these cranks here, damn near every LS crank, a 4-inch stroke crank, takes some Mallory metal. So we'll remove a certain amount of steel, and then the Mallory or tungsten, adds in approximately twice the amount of steel.
So what keeps this in here?
Sorry?
What keeps the added weight in
A
there?
press fit.
Okay.
Yep, so it's about a 2,000 press.
Okay.
We have a little fixture over here that just a hydraulic press.
Yeah.
It'll press that Mallory in there and
Okay.
it's not going anywhere.
Cool.
Another thing we do with all our engines is we'll tack weld the reluctor wheel to the crank.
Oh.
It's kind of a thing, you know.
That is
Everybody
a thing.
that's built LS engines, they know that the reluctor wheel might
Yes.
move on you.
If you know LS motors, you know that that's been a thing. So,
Exactly.
are these all finished balance cranks?
No, these are
Okay.
not finished balance. These are all finished balance
Okay.
here. And
These are all cranks to balance.
These are all cranks to balance
Awesome.
going in engines, man. These
Wow.
are all new or
That tells you how much work they got. You said you had a 400 motor backlog right now?
no.
Okay.
I'm glad I don't have a 400.
Okay. That's what I thought you said. I was like, oh my god.
I think we're about at 60 or so, but
Oh, okay. Hey, that's still really good.
We keep them
You
cranking,
told me
man.
you had 400. You've
We're
done
building
400
400
this year.
a year.
I got you. Okay. That's awesome though.
Yes, sir.
Even 60 to me to get those done is overwhelming. So I can't imagine.
So
That's crazy.
what we're doing, actually, let's go fast here, brother. We'll put the Mallory in right here.
Yep.
So as an example, so you can feel how heavy that is compared to.
Yeah. Check that out. Yeah. Cool.
Yep. So pretty straightforward. We machined it on here. Go right back to the balancer. This thing is basically set up. That's all we do on it is put heavy metal in.
Right.
It's kicked off to the side. You put the crank right in here, clamp it, drill it.
Cool.
Good to go.
I like it.
Another thing that we do is really critical to the longevity of an engine is the way that we polish the cranks. So we get them to a 2RA or better surface finish.
Okay.
There's a lot of crank grinders out there. You'll get a crank back from a crank grinder and it might measure 8, 12 RA, more, and then sometimes it's just very inconsistent, right? So if one might measure 4 and the next one measures 10, that's a big problem.
Is that the best way to describe that? Is that the smoothness of the crankshaft?
Right, yep.
Okay.
So the RA is your roughness average.
Okay.
So we have a specific method. I use the word recipe a lot because that's really what it is.
No, it is. You're right.
So of belts that we use to achieve that surface finish, because we did a lot of testing, and what we really, what's visually what looks smooth is not necessarily smooth.
For sure.
So you would bring two people over and you're like, hey, which one looks better to you? And they'll maybe pick the one that looks shiny or something like that. And you're like, well, the profilometer don't lie. You know?
Right.
And so we really had to go away from what the looks and what really is truly smooth and not. So there's all of this is to try to find those random engine failures that nobody
knows why they did it.
Right? So
why did they do that? We don't really know. But
another thing that we do to our engines, which is super critical, is the way that we machine each crankshaft. So the only thing that we outsource in our whole process is our crank grinding. We have a very special gentleman that takes care of that for us, and that's all he does is grind cranks. And we have very specific numbers, and we true up and we grind every single crank to a specific journal diameter.
Right.
And that, going in conjunction with our line honing process, allows us with the selection of our bearings to, as well as the surface finish, all of those things, like, you get these random number 2 and number 4 bearing failures in a lot of LS engines. Our engines don't do that because of the process in which we have developed.
Right.
And that's really...
Which is back to what you say, the recipe.
It is, man.
It's all what you
and
figured
it's consistency. So if you're building 400 engines and you have, a percentage that one engine, you know what I mean, is not good. So we were on a quest, over the last years to figure out why we would get, this engine that had an issue. Because we know we're doing all the things that, we check them all. We check all 5 main bearing clearances, all 8 rod bearing clearances. When you have an issue and you start really diving deep into why that occurred, you start finding out the things that I was just explaining to you.
Yeah, absolutely. That makes sense.
Once the engine block is deburred, we'll literally go by and deburr the top of the cylinders, the bottom of the cylinders, every aspect, just so it's a finished product. We'll go down back into here into our cleaning area. This jet wash is only used for final cleaning blocks.
Okay.
So once it comes out of this machine here, we swing it over into this here, which is just a rinse tank. We have a hot water heater that has like 120 degree water. so we don't flash rust the part from putting cold water on a hot block. So we get that, we run clean water through it, the brushes, all that, put it on a stand. We'll then keep it from rusting is the biggest thing.
Yeah.
Rust is definitely the enemy. And then it will go through a final process of cylinder wall preparation, really trying to final clean and get any kind of debris out of the cylinder wall.
You just have to wipe the seal up, get stuff in and out.
Yeah, exactly. Engine stand,
engine carts and things like that.
Yep. Yeah. So the cleanliness, I can't stress that enough. I mean, you can do all the best machine work in the world, and if the block is not clean and the parts are not cleaned properly, you can have a great build go to shit because of debris.
Well, one of the things I've noticed about this place, it is clean. So, I mean, I can tell that that's what you guys live by is clean, clean, clean.
No doubt. A little bit about our cylinder head process. I'll show you, after I show you the assembly room, I'll show you a couple of the CNC things. But keeping with the process, we'll come out of the CNC and then we'll come to this line. This is where our cylinder head machining is done.
Cylinder head section.
Exactly. Okay. So we've got a couple of seat and guide machines, and we've got a couple of guide hones.
Yep.
The valve guides have already been pre-installed before porting on a majority of the cylinder heads.
Yep.
Teresa's finishing the ID of the guide, and that's a very tedious and precision setup.
Yep.
So this young lady is perfect at it.
That's cool.
It's just money.
Yeah.
So once the guides are sized, the cylinder heads can then come to the seat and guide machine, and we will cut a very specific valve job for that particular cylinder head. So in our flow development, in the port development, we solidify a valve job that's going to be used, the particular angles that will be used for that cylinder head. We'll call that up and machine that accordingly.
Right.
Once that's done, we go into this room back here where we'll hand finish the ports into the valve job.
Okay.
So if you ever seen, like, once you valve job a head, you've got a little lip. Now this is somewhat of an example. This hasn't been valve jobbed yet. Here we go, right here. So, so you can feel this.
Where it seats.
Yeah, where the seat meets the port work.
Yeah, right there you can see the machine part where the seat meets the port work. So that's what creates the tight seal with the valve.
Right. So, and then what we're going to do is take it one step further, is by hand blending that lip.
So you always hear, and I don't know if this is still a thing because I'm not the machinist part of this, but you always hear 1 angle, 2 angle, 3 angle, 5 angle valve job, whatever the case is.
Right.
And I know those were always created. Ideally, I think it was the more angles that the valve had to seat, the better it seated. Is that still the case? That's still the same thing, or no?
Well, it's really more about, when you're talking about that, it's more about flow.
Okay.
So you have 1 angle to seat.
Okay.
So let it be a 45, a 50, 55 degree angle. More of a race side is going to have like a 50 or 55 degree. And like your street stuff is going to have a 45 degree. It just lasts longer. Okay. All that. The angles are really you're trying to get that air to come around the valve. Okay. So the more you can
nothing necessarily to do with seating. It has to do with the air going around the valve.
Correct. So we'll run a top cut. Then the seat, a secondary cut, and then another cut underneath that. Okay. That'll help. But then it's the final blending. Is what kind of really fine tunes it and gives you that consistency from cylinder to cylinder. Okay. And from cylinder head to cylinder head. So once the hand blending's done, we'll go and clean the cylinder head. And then we go into this room over here. Basically, we will document all of the spring pressures. We'll check installed height, spring pressures for each setup. We've got all of our springs, retainers, seats and guides, everything that's going to be used.
So when the head's finished, this is the last places.
Exactly. Yeah. So we'll document on the computer. It'll build sheet, so we'll know the seat and open pressure, distance from coil bind, guide clearances, everything. So they get their valves in here, they get the springs in here, they get the keepers, retainers, all that stuff, and then once they're assembled, then they probably go and get boxed up. Exactly. Cool. We're either going to box it up or motor. Exactly. Go to our assembly room. So that's our next step. Okay. So these motors like ready to go type thing? Yeah, so these are different levels of completion. This is actually one of our mule motors, one of our just dyno test engines.
Yeah.
We've got a couple engines that are ready to go. Like that one's ready to be picked up. We've got a couple other ones that are ready to go.
Awesome. Nope. Thank you, sir. Calling about my extended warranty.
Perfect. Of course. Yeah. So once we've machined, cleaned, inspected, we know we're ready to go. We'll come into this room here. This is our final assembly room.
Cool.
We've got a bunch of stuff going on.
So your finished product of your block after it's machined, deburred, everything that needs to happen, it comes here in the engine stand. All your crank is balanced. Your parts are ready to literally assemble the engine.
Exactly correct.
And so this, we call this, I think you would call this like your clean room.
Clean room. There's no grinding.
Yeah.
Anything going on in here. It's just literally clean, finished parts. So
looks like you got about 4 motors going at once right now.
Yep, at 5. Is what we
sorry,
so we got 5 spots. Yeah. You know, we'll lay everything out, start checking bearing clearances, getting cam bearings in, all of that.
Man,
and this is where the magic happens here. We've got a couple examples. This is something that's real similar. This is gonna be like this is a pro drift motor that we're doing.
Okay.
Very similar to what we've got going for you.
Okay.
A little different valve train setup, but
yeah, same block and stuff.
Same block, same heads.
Yeah, cool.
So yeah, I mean, this is an example of the cylinder heads that we got on your guy too.
Yeah, cool.
Dude, it makes some power, man.
Yeah, no doubt. Yeah, I'm excited to be able to tell these guys what we made natural aspirated on with a blower engine. So.
Definitely.
Yeah.
Definitely. More LTs. I mean, really, LTs are where it's at for us. I mean, we're doing more LT engines than LS right now.
Really?
So that kind of transition has happened over the last maybe year or so.
Yeah.
To where, I mean, up until so it's more LT. As you can see here, this is a pretty nice little piston setup.
Look at that. What's so that's a little. This would be an LS.
This is more of this is a race LT setup.
Okay.
So it does not have the fuel bowl.
I was gonna say no DI or DI.
It can run. In this particular application, we're not running the DI.
Okay. Is that why it doesn't have a fuel bowl?
Right.
Okay.
And you can honestly run.
So you can show them this, Richard. So like a lot of the DI motors have a fuel bowl in the middle of the piston. And that's because they're direct injected, and the injector is basically sprays right on the top.
That's
essentially right on top of the piston. So if you're going to run an LT motor and it's not direct injected, you can see there's no pocket. Now most of the LSs, heck, all the big block Chevys, small block Chevys, everything looks like that, really. That's right. So that's how you can always tell an LT motor is by that direct injection pocket.
Exactly.
I remember the very first time we tore one of those apart, I was like, man, what is that? Why is that like that? Yeah.
Craziness.
Heck yeah. I see a little supercharger hiding down there.
Yep. That was actually, so that thing, a little Vortec we got going on there.
Yeah. What was that on?
Giveaway.
It was actually that PRI deal.
Oh, yeah.
So they picked a winner.
Yeah.
And the winner opted to go to the street.
Okay.
To the street blower. So this is more of the race blower.
Okay.
So we are waiting. Vortec actually just let us know they're shipping the blower.
Cool.
We're going to dyno it probably next week.
Cool.
And send that thing out to the winner.
Yeah, I bet
so
they were excited. Where did it end up going?
I don't know the state, but it was a female.
Okay.
She's got a hot rod.
I saw that on your social media
They
stuff.
called her up, and she was like in mid LS swap on another car or something.
Wow.
So
that's cool.
Actually, I think it was the car that she won it for, and then she was like totally abandoned her original engine, because she's getting this.
Because she won one of y'all's badass pieces.
Yeah, so it's gonna be pretty cool, man. We can't wait to get that over there.
That's awesome.
So should be good.
Hell yeah.
I'll show you a couple of the CNC things, and we'll go.
All right.
So we do all of our port development here. So we can use a bunch of nice, high quality castings. We use the Brodix castings. We use CID castings. Edelbrock castings. A lot of the Edelbrock stuff we're taking from the raw casting to the finished product.
I think that's what you put on my motor was an Edelbrock casting.
Yep.
Yeah. So obviously you guys deal with Calis. I see about 50 Calis cranks over there. So you guys were trying to get ahead of the game. I get it. That's
no
cool.
doubt.
A bunch of CID stuff, a bunch of Brodix stuff.
Exactly. I'll show you some more.
Yeah. covers?
Yeah, so what it's doing is...
So that machine is making this.
Oh, wow.
A beautiful piece of billet. What this is a valley cover for.
So it's for an LS engine.
Yep.
And a couple of features that we've got incorporated in this thing is we're running 2-12 breathers. And then we have some provisions for oil pressure. We're running, and then you have 2 other ports to, let's say, feed oil squirters or other references.
Or just if the angle is not right, you can use the other one. Yeah.
Yep. So the 2-12s, and then I want to show you something that we have. So we have a nice baffle system. We make another part that comes up underneath here.
Yeah.
We put some media inside there, and that's our, you know, you got to shield the oil from getting into your breather.
Yeah.
So this is proven to work really nice, and it's got a new product that we actually have.
That's cool. And that's for LS only?
It's for LS only, and we have an LT that we're working on as well. So it's machining that right now. Then we have a bunch of customer blocks in process.
Wow.
So once they get disassembled, cleaned, they're going to come up here, just staged for machine work.
Okay. So this is ready to go in the CNC machine.
Yeah. So these have all been validated, primarily clean, degreased.
Is this safe to say how far, I'm going to use the word loosely, but behind you are? Which is, but it's not really behind. It's
not behind, but so this is just all in process.
Yeah, that's cool.
Yes, sir. This is making runners for the intake manifolds. Okay. So again, there's 2 in there. This is all running second operation. So once it comes out of here, it'll be basically a finished runner without the interior, without the port done. We do the port in the 5-axis.
Cool.
Yep. Doing a lot of this is a line bore. So this is a machine that we use to bore the billet main caps. Okay. So like some of your LS, a lot of the Hemis, we're putting steel caps on them. Yeah. From the factory. Viper, we put some billet caps on. So this one here, we're machining for like a hoop, the top fuel hoop. Oh yeah. Yep. So it's got an end mill that we're actually machining for that hoop. So we machine it for a specific width and diameter, and depth. So that's running, and then we have another 5-axis. So we do all the porting in both of these machines here. Okay. This one's getting after. You can see how that head just
that's
gets down in there, man. It's sick, man.
What they can do these days with these CNC machines is unbelievable.
Yeah, I love it, man. It's like
God, hey, did you ever think when you were grinding on cylinder heads in your garage,
never,
you could be able to do this one day?
Never, man. We you know, it's like the first CNC machines that we've seen, we're like, oh yeah, you know, it's unreal.
Yeah, one day when we're rich, maybe we'll buy one of those.
Yeah, so this is kind of an example of taking the cylinder head from the raw casting to the finished product.
Oh wow. So what is this? I know what it is. Whose is it?
So this is an Edelbrock raw casting. This is based off of their LSR casting. Okay. So this is actually a hip casting, which means that it's a lot denser than a standard aluminum casting. Yep. It gives it the density of almost of billet. Okay. So you know, billet cylinder head is obviously a great thing, very expensive. If you can do it out of a casting and then have that hip process done, you've got a very strong, rigid cylinder head. May not be quite as strong as billet, but it's close. It's real damn close. So what we've got is we take this, we've done all of our programming and you know, port development, the whole 9 yards, and ultimately what you end up with is a transformation from this raw casting to the finished piece. A beautiful cylinder head. So you take this guy, you put in this CNC machine, and you end up with this guy. We've made 1100 horsepower with this cylinder head naturally aspirated. We had you know, well over 2,000 horsepower in like a turbo application. Wow, that's beautiful. That's unbelievable. And how long do these things sit in that? What's it take to do one of those? So it's about a 3-operation process to get it through. Yep. Depending on, like, this one's has a little bit more machining than others. Yeah. About a 7-hour process, 7-8 hours. Wow. That's a lot of material you gotta take off. It's crazy. Yes, sir. Making valve covers in this one here. Finished product? That is semi-rough. I think we're proving out some programs on a new setup. So we have this in the no coil. And we're proving out the coil setup.
So essentially, you take this chunk of aluminum and you turn it into that, but even nicer than that. That's a rough version.
Down here, grab one of those. That's the no coil finished product.
Oh, okay. Yeah.
So it's got the oil fill cap for the wet sump, 2-10 breathers.
Does the CNC machine cut these holes?
It does.
And thread them?
Yep.
Wow.
It thread mills it.
Wow.
So you actually have a cutter that's spinning, of course, and then it comes in and cuts the thread.
Wow. That's beautiful. That's unbelievable. Cool. So that's the magic behind the LME, huh?
That's it, man. We've got we're trying to manufacture and produce products that solve problems, build the best engines, keep everybody hauling ass.
Well, I'm excited to have one of you guys' motors. I've heard about you guys for a long time, and being that you're in Houston, I never really had the opportunity to come down here. But since we got together on this project and you're doing a LT for me, I'm excited. And then just I don't know what to say. Your expectations, you have so far exceeded the expectations of what I was thinking when I walked in. It's unbelievable. Awesome. So hats off to you just for what you've made here.
Thank you.
Congratulations. I know you started. A lot of people don't know your history, but you started from porting cylinder heads in the garage.
Yep. Myself and my partner, man, we just got busy and grabbed a grinder. And,
and here you are,
kind of evolved into all this.
And here you are today, one of the most successful engine shops in Houston. Fucking good job.
Awesome, man. Appreciate it.
Yeah.